A jet aircraft is an aircraft propelled by jet engines. Whereas the engines in propeller-powered aircraft generally achieve their maximum efficiency at much lower speeds and altitudes, jet engines and aircraft achieve maximum efficiency at speeds close to or even well above the speed of sound. Jet aircraft generally cruise at faster than about Mach 0.8 and around 10,000 to 15,000 meters or more. Frank Whittle, an English inventor and RAF officer, developed the concept of the jet engine in 1928. Hans von Owen in Germany, a decade later, developed the concept independently at the end of the 1930s. He wrote in February 1936 to Ernst Haenkel, telling him of the design and its possibilities. However, it can be argued that the English engineer A. A. Griffith, who published a paper in July 1926 on compressors and turbines, also deserves credit. History. A number of jet power plants were suggested from the first instances of powered flight. Rena copyright Lauren, Marais, Harris proposed systems for creating a jet efflux. In 1910 the Romanian inventor Enrico Florin filed a patent on a jet propulsion system which used piston engine exhaust gases to add heat to an otherwise pure airstream compressed by rotating fan blades in a duct. Rocket-powered jet aircraft were pioneered in Germany. The first aircraft to fly under rocket power was the Lippisch Ent, in 1928. The Ent had previously been flown as a glider. The next year, in 1929, the Opel RAK-1 became the first purpose-built rocket plane to fly. The turbojet was invented in the 1930s, independently by Frank Whittle and later Hans von Owen. The first turbojet aircraft to fly was the Heinkel He-178 prototype of the German Air Force, the Luftwaffe, on August 27, 1939 in Rostock. The first flight of a jet-engined aircraft to come to popular attention was the Italian Caproni Company N1 motorjet prototype that flew on August 27, 1940. It was the first jet aircraft recognized by the FAR copyright DAR copyright Ration or copyright Ronautique Internationale. Campany had proposed the motorjet in 1932. The British experimental Gloster E-28/39 first took to the air on May 15, 1941, powered by Sir Frank Whittle's turbojet. The United States produced the Bell XP-59A with a version of the Whittle engine built by General Electric, which flew on October 1, 1942. The Meteor was the first production jet as it entered production a few months before the Me-262. The first operational jet fighter was the Messerschmitt Me-262, made by Germany during late World War II. It was the fastest conventional aircraft of World War II, although the rocket-powered Messerschmitt Me-163 Comet was faster. It had first flown in 1941 but mass production started in 1944 with the first squadrons operational that year, too late for a decisive effect on the outcome of the war. About the same time, mid-1944, the United Kingdom's Gloster Meteor was being committed to defence of the UK against the V-1 flying bomber itself a jet-powered aircraft and then ground attack operations over Europe in the last months of the war. In 1944 Germany introduced into service the Arado R-234 jet reconnaissance and bomber, though chiefly used in the former role. USSR tested its own Betsiak Bi-1 in 1942, but the project was scrapped by Joseph Stalin in 1945. The Imperial Japanese Navy also developed jet aircraft in 1945, including the Nakajima J-9 Waikika, a modified, and slightly smaller version of the Me-262 that had retractable wings. By the end of 1945, the U.S. had introduced their next jet fighter, the Lockheed P-80 Shooting Star, into service, and the UK its second fighter design, the de Havilland Vampire. The U.S. introduced the North American B-45 Tornado, their first jet bomber, into service in 1948. Although capable of carrying nuclear weapons, it was used for reconnaissance over Korea. On November 8, 1950, during the Korean War, United States Air Force Lieutenant Russell J. Brown, flying in an F-80, intercepted two North Korean MiG-15s near the Yalu River and shot them down in the first jet-to-jet dogfight in history. The UK put the English Electric Canberra into service in 1951 as a light bomber. It was designed to fly higher and faster than any interceptor. BOAC operated the first commercial jet service, from London to Johannesburg, in 1952 with the de Havilland Comet jetliner. This highly innovative aircraft travelled far faster and higher than the propeller aircraft, was much quieter, smoother, and had stylish blended wings containing hidden jet engines. However, due to a design defect, and use of aluminum alloys, the aircraft suffered catastrophic metal fatigue which led to several crashes. The series of crashes gave time for the Boeing 707 to enter service in 1958, and this came to dominate the market for civilian airliners. The undesigned engines were found to be advantageous in the advent of a propellant leak, and so the 707 looked rather different from the Comet. The 707 has a shape that is closer to modern aircraft. Turbofan aircraft began entering service in the 1950s and 1960s, bringing far greater fuel efficiency, and this is the type of jet in widespread use today. The Tu-144 supersonic transport was the fastest commercial jet plane at Mach 2.35. It went into service in 1975, but soon stopped flying. The Mach 2 Concorde aircraft entered service in 1976 and flew for 27 years. The fastest military jet plane was the SR-71 Blackbird at Mach 3.35. Other jets. Most people use the term jet aircraft to denote gas turbine-based air-breathing jet engines, but rockets and scramjets are both also propelled by jet propulsion. Cruise missiles are single-use unmanned jet aircraft, powered predominantly by ramjets or turbojets or sometimes turbofans, but they will often have a rocket propulsion system for initial propulsion. The fastest air-breathing jet aircraft is the unmanned X-43 scramjet at around Mach 9 a Euro 10. The fastest manned aircraft is the X-15 at Mach 6.85. The Space Shuttle, while far faster than the X-43 or X-15, was not regarded as an aircraft during ascent as it was carried ballistically by rocket thrust, rather than the air. During re-entry it was classed as an unpowered aircraft. The first flight was in 1981. Aerodynamics. Because of the way they work, the typical exhaust speed of jet engines is transonic or faster, therefore most jet aircraft need to fly at high speeds, either supersonic or speeds just below the speed of sound, so as to achieve efficient flight. Aerodynamics is therefore an important consideration. Jet aircraft are usually designed using the Whitcomb area rule, which says that the total area of cross-section of the aircraft at any point along the aircraft from the nose must be approximately the same as that of a Sears-Hawk body. A shape with that property minimizes the production of shock waves which would waste energy. Jet engines. Jet engines come in several main types: turbojet, turbofan, rocket. The different types are used for different purposes. Rockets are the oldest type and are mainly used when extremely high speeds or extremely high altitudes are needed. Due to the extreme, typically hypersonic, exhaust velocity and the necessity of oxidizer being carried on board, they consume propellant extremely quickly. For this reason, they are not practical for routine transportation. Turbojets are the second oldest type. It has a high, usually supersonic, exhaust speed and low frontal cross-section, and so is best suited to high-speed, usually supersonic, flight. Although once widely used, they are relatively inefficient compared to turboprop and turbofans for subsonic flight. The last major aircraft to use turbojets were Concorde and Tu-144 supersonic transports. Low-bypass turbofans have a lower exhaust speed than turbojets and are mostly used for high sonic and transonic and low supersonic speeds. High-bypass turbofans are used for subsonic aircraft and are quite efficient and are widely used for airliners. Propulsive efficiency. In aircraft, overall propulsive efficiency is the efficiency, in percent, with which the energy contained in a vehicle's propellant is converted into useful energy, to replace losses due to air drag, gravity, and acceleration. It can also be stated as the proportion of the mechanical energy actually used to propel the aircraft. It is always less than 100% because of kinetic energy lost to the exhaust, and less than ideal efficiency of the propulsive mechanism, whether a propeller, a jet exhaust, or a fan. In addition, Propulsive efficiency is greatly dependent on air density and air speed. Mathematically, it is represented as where is the cycle efficiency and is the propulsive efficiency. The cycle efficiency, in percent, is the proportion of energy that can be derived from the energy source that is converted to mechanical energy by the engine. For jet aircraft, the propulsive efficiency is highest when the engine emits an exhaust jet at a speed that is the same as, or nearly the same as, the vehicle velocity. The exact formula for air-breathing engines as given in the literature, is where c is the exhaust speed, and v is the speed of the aircraft. Range. For a long-range jet operating in the stratosphere, the speed of sound is constant, hence flying at fixed angle of attack and constant Mach number causes the aircraft to climb, without changing the value of the local speed of sound. In this case, where is the cruise Mach number and the speed of sound? The range equation can be shown to be, which is known as the Breguet range equation after the French aviation pioneer Louis-Charles Breguet. See also, Coan de Florin -1910, Commercial Aviation, Contrail, Jet Airliner, Jet Noise, Jumbo Jet, List of jet aircraft of World War II, Very Light Jet, Notes. References, Citations. Bibliography, Lutz Warsitz, The First Jet Pilot. The story of German test pilot Erich Warsitz, Pen and Sword Books Limited, England, 2009, ISBN 978-1-84415-818-8, English edition. External links, the official Erich Warsitz website, inclusive rare videos and audio commentaries.